Ben is the co-founder and technology manager at Quantica in
Hello.
Berlin.
Yeah. Thank you
And
for
he
having me.
will talk about breaking barriers in 3D printing, jetting functional high-viscosity materials. Perfect. Ben,
Oh, perfect. All right.
awesome. The stage is yours. Enjoy.
All right. Yeah, thank you for having me. So I'm Ben Hartkopp, co-founder and technology manager of Quantica GmbH, based in Berlin. So yeah, my talk is about breaking barriers in 3D printing, the jetting of functional and high viscosity materials. So essentially what we've done is we founded Quantica in 2018. So this was between Ludwig Färber and myself, starting the development of a printing system for inkjet 3D printers that was actually supposed to initially print PCBs. And we've been developing some chemistry printheads as well as the entire system around that, and have been discovering that we have the capability with our new printhead to eject very highly viscous materials, but also other types of rheological properties that were not possible before. And so from that, we've started to grow. We have now the complete in-house development of firmware, hardware, software, electronics, and materials. And we have now, I think, more than 50 full-time employees, and are still hiring top scientists, engineers, and people with management skills. We were very lucky to get some colleagues that are former employees of some of the technical leaders in printheads as well. And with this, we've started to basically deliver a new deep technology development in printheads, protect the IP of all of that and certain subsystems. And with this core technology, we believe we have a huge impact potential on different multiple markets and applications because of the increased range of chemistry that is available for the jetting process. We've sort of validated this with existing industrial partnerships formed while in development, yeah, in many different fields of materials. And this has led us to basically develop an open system for application, research, and development. Yeah, with the mission to basically give our customers the full freedom to print. And this is, you know, with the classic freedoms that inkjet provides, so voxel by voxel control, multi-material, color, and even functional materials. And because of the highly viscous or high complex rheological properties that are able to be jetted, also very high performance material set. And all of this is going to be done in one single process. So we have some current limitations in the existing markets, mainly relating to viscosity and rheology. And these stem from the functional principles of existing printhead technology. And you can see some comparative chart where you can see that we have, in one extreme case, ejected a material, was a composite material with up to 60% particle loading as well, that had a viscosity of 380 amperes at the jetting point. This translates to around 4,000 millipascals at room temperature in this case, also with pretty high particle loading and large particle size. This doesn't mean, of course, that this is the same for every material, but this is one example where we are sort of magnitude ahead of the legacy type of inkjet printing heads, with one competitor being a little bit higher than the rest, essentially. And yeah, and you can see some of the materials that we've successfully printed in some dual material applications in our older in-house systems. So we have a denture, it's sort of a mock denture that is two components with two certified dental materials, also for in-mouth use. Then we have highly elastomeric materials combined with high-strength polymers in this sort of finger example and this mock-up wearable. And all of this is enabled by our NovoJet printing head technology. So here you can see a little bit of process video, how we utilize this in our in-house developed T1 Pro printers. These are basically our research systems. And this allows the printing of, again,